Welcome back. We're going to talk about finding the exact trig values from a given point. We're going to talk about finding 6 trig functions. Before we only talked about sine, cosine, and tangent, so we're also going to talk about secant, cosecant, and cotangent. Just real quick off to the side here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We also have their other 3 other ones. This one is cosecant, which is the hypotenuse over the opposite. We have the secant, which is the hypotenuse over the adjacent. And we have the cotangent, which is the adjacent over the opposite. So we're going to use those in order to construct our triangles within our circles using trig ratios. This is where it gets a little more in depth. So finding exact trig values from a given point. So we're going to use the point that the terminal side goes through or a given ratio. We can construct a right triangle to calculate exact trig values of an angle. And we're going to find all those 6 trig values: sine, cosine, tangent, cosecant, secant, and cotangent. So the terminal side of an angle, that's the one that moves, passes through the point -4, 7. Find the 6 trig functions of that angle, theta. First thing I'm going to do is I'm going to draw my coordinate plane. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. I'm going to draw a triangle that goes through that point, because if I had my angle, let me do this in red. My terminal side moves. Terminal side is going to go to here, pass through that point. So I can actually create a triangle based on that, a 90-degree triangle, which just is -4 and 7. I'll need to find, in order to find my hypotenuse, I'll need to use Pythagorean theorem. So 7 squared plus -4 squared equals c squared. 49 plus 16 equals c squared. Do some math off to the side here. 49 plus 16, 65, c squared. Then the square root. So c is going to be equal to the square root of 65. It'll only be positive because we are talking about distance. 65, by the way, just some of you might be wondering, that's 13. Sorry, it's 13 times 5, which won't break down. So square root of 65. So now knowing this, I can find each of those. So sine, think of it as my angle is here. Angle will always be in there. That's one of the reasons that we learned reference angles in the last video. So sine will be 7 over the square root of 65, which is 7 square root 65 over 65. Cosine, -4 over square root 65. So -4 square root 65 over 65. And then my tangent is -7/4. Secant. Cosecant, secant. I like to make sure that I keep them all in order here. Cosecant, secant, and cotangent. This is going to be square root of 65 over 7. I'm just flipping my fraction. Square root of 65 over -4, or negative square root 65 over 4, and negative 4/7. So there we were able to find all 6 trig functions. Example number 10. The sine of theta is negative 3, 4, and the terminal side lies in Q3. Find the 6 trig functions of theta. So here I'm going to draw my coordinate plane. I'm going to draw an angle in Q3. And I know that this is my opposite and this is my hypotenuse. Now, here's a little trick to note, is hypotenuse is always a distance, so it'll never, ever be negative. So 4 will go here. This is theta, my opposite side, negative 3. Now I'll have to figure out what this side's going to be. So negative 3 squared plus x squared equals 4 squared. So 9 plus x squared equals 16. X squared is equal to 7. So x is equal to the square root of 7. And it will be a negative square root of 7 because I'm going into Q3. X and y are both negative in Q3. Once we have this down then, again, I'm just finding my sine, cosine, and tangent, my cosecant, my secant, and cotangent. So with my sine, it already gave me, it's negative 3/4. My cosine, negative square root 7 over 4. And then my tangent, I have 2 negatives that create a positive. So I'll have 3 over the square root of 7, which will be 3 square root 7 over 7 when I rationalize. And then I'm flipping my fraction for my cosecant. So negative 4/3, negative 4 square root 7. So this will be negative 4 root 7 over 7. And then this is going to be the square root of 7 over 3. Last example here, find the 6 trig functions if the terminal side goes through 2 square root 5 comma negative 1. So I've got to figure out where that's going to be located. I know I'm going to be going to my right because my x is positive and then my y is negative. So it's going to be a very small triangle here. Actually, it's going to be something, I'll just blow it out of proportion here. I'll make this 2 square root 5, and then I'm going to go down negative 1. So I've got to figure out what this is going to be. So 2 square root 5 squared plus x squared equals 1 squared. So 4 times 5 is 20 plus x squared equals 1. So x squared is equal to negative 19. And it looks like this side's just not going to exist. It might be in part because this doesn't match, like these two will not create a triangle. So I'm just going to say does not exist. And that should be it. If I made a mistake, you guys, I'm sure you'll catch it in class or you'll send me a message and be like, hey, Mr. Stewart, you might have missed something. But if you can't create the triangle, you can't create the... Oh, you know what? I did miss something. I'm trying to find the hypotenuse. Whoa, whoa, whoa. Back up here. This is not, do not exist. I set up my Pythagorean theorem incorrectly. I already caught it. Squared is equal to x squared. There it is. Okay. So this is still going to give me 20 plus 1 equals x squared. Aha! So 21 is equal to x squared or the square root of 21. There we go. Okay, now I can figure this out. So sine, cosine, tangent, cosecant, secant, and cotangent. Remember, it's always the reference angle there. It's where the angle is going to be. So first off, I've got my sine, so -1 over the square root of 21, which is going to be negative square root 21 over 21. Cosine, 2 square root of 5 over the square root of 21. So that'll be 2 square root of 21 times 5. So 105 over 21. And then my tangent, which is -1 over 2 square root 5, or negative square root 5 over 2 times 5, which will be 10. And I can't simplify because that 5's underneath the radical. Cosecant here, I've got negative square root of 21 over 1, or just the negative square root of 21. I've got the square root of 21 over 2 square root of 5. So that'll be the square root of 105 over 10. And then I'll have -2 square root of 5 over 1, which is the same thing. All right, and there you go.